Today we are going to discuss solution of non-homogeneous ODEs with constant coefficients. And for that, you can say solution of non-homogeneous linear ODEs with constant coefficients. I hope you know how to write a general nth order linear homogeneous ODE. We can write it in this form: a n y n nth derivative plus a n minus 1 y n minus 1 plus so on plus a1 y dash plus a naught y is equal to some function g of x. Here g of x should not be 0 if this differential equation is non-homogeneous. This differential equation can be written in this form: an dn plus an minus 1 dn minus 1 plus so on plus a1d plus a naught times y of x in fact is equal to g of x. I told you that d is an operator such that dk by dk is equal to dk by dxk. Okay, so if we use this operator, we can write this differential equation in this form. Now, I hope you know how to solve homogeneous differential equation. This is, we call it equation 1. Then the associated homogeneous equation, or ODE is what? The homogeneous ODE associated with this equation is basically this whole thing is equal to 0. So we can say that an dn plus an minus 1 dn minus 1 plus so on plus a1d plus a naught times y y of x is equal to 0. This is the associated, the homogeneous differential equation associated with this non-homogeneous ODE. Now, I hope you know how to how to solve. In the previous lectures, we discussed only how to solve this homogeneous linear nth order differential equation with constant coefficients. We have discussed different cases of by finding the roots of the corresponding characteristic equation of this homogeneous ODE. We can write the general solution of this homogeneous differential equation. We have discussed in detail how to solve this. Now today we are going to discuss how to solve this non-homogeneous differential equation. So first of all, we need to know what is the general solution of the non-homogeneous differential equation. General solution of basically non-homogeneous ODE. Obviously, non-homogeneous with constant coefficients. Okay, with constant coefficients and also linear. Let me add the people. So the general solution of the ODE1 ODE1 आप कह लें यहाँ पे ODE1 जो कि हमने पिछले इस पे बोर्ड पे लिखी. The general solution of that ODE is what? It is the sum of yc of x plus yp of x. Now, what is yc of x? Yc of x is complementary solution. Complementary function or complementary solution, we call it. Complementary function or solution. Second thing, yp. Yp complementary function solution is basically what? We call it yc of x. Now, second is particular integral. Particular integral or particular solution. And we denote it by yp of x. So the general solution of the non-homogeneous ODE of nth order with constant coefficients is basically is a sum of complementary solution and particular solution. Now, what is complementary solution or complementary function? Complementary function yc of x is the solution of the corresponding homogeneous ODE2. That was this one. If we solve this differential equation, we get a solution of this, solution of this differential equation, solution of 2, which is the associated homogeneous differential equation. Solution of 2 is called yc of x, which is basically we call complementary function. And the solution, and what is the particular integral yp of x? I hope you know what is particular solution. A particular solution is the solution which is independent of arbitrary constants. We discussed it in the early lectures of this course. Yp is what? Is the solution of, yp is what? Is solution of 1. 1 is what? It is non-homogeneous differential equation. Non-homogeneous differential equation with constant coefficient. So yp is a solution of 1, which does not contain arbitrary constants. Arbitrary constants means constants of integration and so on. Now, further, what is yc? Yc, I told you, it is the solution of the associated homogeneous differential equation. Now, what is the solution of homogeneous differential equation? It is basically the general solution of that ODE2, which can be written as C1 y1 of x plus C2 y2 of x plus so on plus Cn yn of x. You know that the general solution of homogeneous ODE, linear homogeneous ODE of nth order with constant coefficient, is basically it has n linearly independent solution. It forms a fundamental set of solutions, and we can write the general solution of the homogeneous ODE as a linear combination of n linearly independent solutions. So this is the general solution of homogeneous ODE. And the general solution of non-homogeneous ODE with constant coefficients is the sum of complementary function and particular integral. Now, we know that how to find this complementary function yc of x. Now, how to find, now the question is how to find this particular integral or the particular solution of that non-homogeneous differential equation. how to find yp of x. There are two methods uh, for finding yp of x, which we are going to discuss in this course. One is method of undetermined coefficients. And the second method is method of variation of parameters. So these two methods help us to find the solution of the particular solution of the non-homogeneous ODE1. So today we are going to discuss the first method of undetermined coefficients. Let me change the board. Before discussing that method, let us have an example of particular integral. I have included example here in my notes. This one. Example. Consider the following ODE, or find the general solution of. Find the general solution of this ODE y triple dash minus 6y double dash plus 11y dash minus 6y is equal to 3 times x. Now, you can see that this method is only applicable. You should remember that this method is only applicable. Sorry. We'll discuss it later after doing this example. Now, we need to find the general solution of this thing. Still, we do not know what is a particular solution. Suppose that particular integral is given that particular solution yp is what? Yp is minus 11 by 12 minus 1 by 2x. Yp is given. Now, what we have to find? We have to find the yc of this differential equation, not this associated. We need to find yc, means complementary solution of the associated homogeneous ODE, given ODE. Now, the associated homogeneous ODE of this given differential equation is what? It is y triple dash minus 6y double dash plus 11y dash minus 6y equal to 0. Now, we need to find yc of this associated homogeneous differential equation, and then we can find the general solution of this differential equation because yp is given. So the general solution of this differential equation is what? It is the sum of particular integral and complementary solution. this is particular solution. Why it is particular solution? Because this function satisfies this differential equation. You can verify it. Okay, verify that this function is a solution of this differential equation. I hope you can do it. Now, if we insert this function here in this differential equation, both equations, both sides of the equation would be equal, would become equal. So this is a solution, and why we call it a particular integral or particular solution? Because this solution does not contain any arbitrary constants. Now, we can solve this easily. We can write its characteristic equation. Characteristic equation, if we write it here, it would be m cubed minus 6m squared plus 11m minus 6 equal to 0. And after solving it, we get the roots 1, 2, 3. And y, we can write yc, obviously c1 e raised power 1x plus c2 e raised power 2x plus c3 e raised power 3x. Because the roots are real and distinct, so we can write the yc in this way. The general solution in this case will be, therefore, the general solution of ODE1, which is non-homogeneous linear third order differential equation with constant coefficients. So y of x is what? It is y c of x plus yp of x. Now yc is this and yp is this. We write the sum here and we get the solution. So it is c1 e raised power x plus c2 e raised power 2x plus c3 e raised power 3x minus 11 by 12 minus 1 by 2x. So this is the general solution of the given non-homogeneous ODE. Now here still we are given particular integral. Before discussing how to find particular integral, we are going to discuss first the superposition principle for non-homogeneous ODEs. In the previous lectures, we discussed superposition principle for homogeneous ODEs. Now we are going to discuss superposition principle. Principle of superposition क्या दें आप? Principle of superposition for non-homogeneous ODEs. What is this principle of superposition? In short, I'm going to tell you, if we have a differential equation, nth order, an, you can write bn, plus an minus 1, dn minus 1, plus so on, plus a1d plus a naught, y is equal to g of x. Now we have here we have a single function. If we call it yi, where I is from 1 to up to so on, maybe k. Now this is nth order ODE non-homogeneous with gi of x, where I is from 1 to k. We have how many functions do we have here? K functions, k different functions. Means g1 of x, g2 of x, and so on, gk of x. Also known that these all functions are distinct. They're not identical, distinct. So how many differential equations do we have here now? K differential equations. We obtain K ODEs. If we have K ODEs, then we must have K particular solutions. So if YPI of x, where I is from 1 to so on K, okay, are particular solutions of the corresponding ODEs. Corresponding ODEs means YP1 will be the solution of this differential equation with G1. YP2 will be the particular solution of basically the same differential equation. Left hand side would be same, but the right hand side here we have G2 of x, and so on. YPK is the solution of left hand side same, right hand side we have GK of x. We have K differential equations and we have K particular solutions. Then the principle of superposition tells us that then Yp of x is equal to Yp1 of x plus Yp2 of x plus so on plus Ypk of x in sum of all particular solutions. Then this will be or is a particular solution of the following ODE, which is an dn plus an minus 1, dn minus 1 plus so on, plus a1d plus a naught y is equal to g1 of x plus g2 of x plus so on plus gk of x. This one. So what we have done here, we said that Yp1, Yp2, so on, Ypk, they are solutions of those individual ODEs. Individual ODEs means separate ODEs with G1, G2, so on, Gk. Then principle of superposition for this case, for the non-homogeneous ODEs, it tells us that the sum of the particular solutions will be the solution of the sum of right hand side, basically what we have done here, sum of the right hand side functions of all those ODEs with the same left hand side. Left hand side remains same, but here we took the sum of all right hand side functions. So this is basically the solution. This is solution corresponding to G1, this is solution corresponding to G2, and this is a solution corresponding to Gk. Then the sum of all these particular solutions will be basically solution of this differential equation in which we can add up the right hand side functions. So this is basically principle of superposition in this case, where the differential equation is non-homogeneous. Okay, I hope you get it. If you have any question, you can ask me. For example, let us discuss an example of this thing. Now, let us assume that example, if I have a differential equation, for example, this one, y double dash minus 3y dash plus 4y is equal to minus 16x squared plus 12, 24x minus 8. This differential equation has a particular integral, for example, yp1 of x, and it is minus 4x squared. You can verify that this is a solution of this differential equation by inserting that function into this. Consider another with the same left-hand side. Left-hand side remains same. Another differential equation with the right-hand side now changes, this one. In this case, the yp2 of x means another particular solution is what? It is e raised to the power 2x. You can also verify that this is the solution of this. This is 1, this is 2, and this is 3. Another differential equation, y double dash minus 3y dash plus 4y equal to 2x e raised to the power x minus e raised to the power x. And the particular solution of this differential equation is what? X e raised to the power x. Now we have 3 differential equations and 3 particular integrals. But note that the left-hand side in all these 3 differential equations is same. Only the right-hand side is different. So this is, we call it g1 of x. This right-hand function, we call it g2 of x. And this function, we call it g3 of x. Then we have 3 particular solutions. Then by principle of superposition, we can say that, or we can write that yc of x, it is yp1 of x plus yp2 of x plus yp3 of x. That is, you can write the individual solutions here. Yp1 of x is minus 4x squared plus e raised to the power 2x plus x e raised to the power x. This is the solution of the following ODE. Now the ODE is what? Y double dash minus 3y dash plus 4y is equal to, you can write all the 3 functions on the right hand side, minus 16x squared plus 24x plus minus 8 plus 2 e raised to the power 2x plus 2x e raised to the power x minus e raised to the power x. So this is your G3, this is your G2, and this is your G1. Okay. So this is your G1 of x, this is your G2 of x, and this is your G3 of x. So this is what we call principle of superposition for finding complementary solution of the nth order linear non-homogeneous differential equation with constant coefficients. I hope you get it. If you have any question, you can ask me. Now, still, we did not discuss how to find the particular solutions. Okay, now we are going to discuss how to find particular solutions for a given non-homogeneous differential equation. If you have any question in this principle of superposition, you can ask me. I told you that in order to find the particular solution of these kind of differential equations, with constant coefficients, non-homogeneous, we use two methods. We can use two methods. The first is method of undetermined coefficients, and the second is method of variation of parameters. Now we are going to discuss the first method, which is method of undetermined coefficients. Method of undetermined coefficients. We can guess by its name that there must be some kind of undetermined coefficients in this method, which we have to determine, which we have to calculate. Now, the method of this undetermined coefficient, in this method, we basically make an educated guess as a particular solution. Okay. Basically, the idea, you can say that the idea behind this method is basically to start with an educated guess. An educated guess which contains some kind of undetermined coefficients. Okay. An educated guess which contains undetermined coefficients. Undetermined, not under. Undetermined coefficients. And how to make this guess? It depends, or this guess depends on the type of or nature of the right-hand side functions. Right-hand side functions. Right-hand side function in that ODE, which is what? G of X. Right-hand side function. Okay. So what is the basic idea in this method is what? We start with an educated guess, which contains undetermined coefficients, and the type of that educated guess, it depends on the nature of the right-hand side function. Right-hand side function of that ODE, which is, we call it in ODE 1, we call it G of X. Now, what type of functions, if we have, or you can say that, what type of functions, if we have on the right-hand side of the ODE, or you can say that this method, when this method is applicable, पहले हाँ इसको डिस्कस कर लेते हैं. When this method is applicable and when this method is not applicable, or we cannot use this method. When applicable. The method is applicable only if the ODE satisfy the following conditions. If, or you can say the method is applicable only if a non-homogeneous ODE satisfies the following axioms or following conditions. The coefficients are constants. The coefficients an minus 1, so on, a1, a0, they're all constants. Okay? We cannot apply this method if non-homogeneous ODE contains variable coefficients. The second thing is, this method is only applicable if the right-hand side function, if RHS function g of x is of the type. What is the type of g of x in this case? Number one, you can say A. G of x is constant. A constant function. G of x is what? It is a constant function. Constant function. पहली type ये है जिसमें हम if we have the right hand side constant, then we can solve this differential. The second thing is g of x is a polynomial function. Polynomial Pn of x. Pn of x is what? A polynomial function of degree less than or equal to n. यहाँ पे n होगा, ठीक है? A polynomial function. Polynomial function. It is a polynomial of degree of some finite degree n. It could be a degree 1, degree 2, degree 3, degree 4 polynomial. Number 3, g of x is exponential function. G of x is some kind of alpha times e raised by beta x. An exponential function. Here you can have some constant, here you can have the constant positive or negative, whatever it is. But the nature of the function g of x is exponential function. This is the third kind of function for which we can solve the differential. The fourth type, another type of the right-hand side function, if the right-hand side function is a trigonometric function of only of the type sine of some maybe constant alpha x or cosine of alpha x. It can contain some constant as well, c times this or c times this. If the right-hand side function is of this type, either sine alpha x, some constant, or cosine alpha x, or the linear combination of both these things. You can say that c1 sine alpha x plus c2 cos alpha x. But this angle should be same. Otherwise, what we have to do, we have to separate two ODEs, and we can use principle of superposition to solve, to find the two different particular solutions, and we can add up those particular solutions to find one particular solution of the given differential equation. DE, either sine or cos, or finally, g of x is a finite sum or sums, finite sums or product of above listed functions. Above listed functions. Means the right-hand side function g of x, we can only, this method is only applicable only if the right-hand side function is constant. It may be a polynomial. It may be exponential function. It may be a sine function or cosine function, or the sums or products of all these functions. It is also possible. Then in this situation, in all these situations, we can apply this method. Otherwise, no. Now, let's discuss some of the functions in which we cannot apply this method. For example, or you can say this method is not applicable. Method is not applicable if g of x is some fractional functions. For example, maybe 2x plus 1 divided by x squared plus 3x plus 9, for example, this one. Then this method is not applicable. Second, g of x is, it involves natural log or some kind of log. This method is not applicable. Second, third, g of x is tangent of x, not applicable, or sine inverse x, not applicable. Okay, so these are the functions. In these cases, this function is not applicable. So this method is only applicable if that ODE satisfies basically these two conditions which we have discussed right now. The coefficients are constant and the right-hand side functions are basically one of these 5 listed kind of function. The fifth one is the right-hand side may be the sums or products of these kind of functions which we have listed earlier here. I hope you get it. If you have any question, you can ask me. Now we are going to discuss the cases, what we can assume as a particular solution in certain conditions or in some particular situations when the right-hand side function is given. For example, example 1. If 13, 14, yeah, before discussing this example, let us discuss this table which I have given you on page 14 of my notes. In this table, I have on one side, I have given g of x, type of g of x, and on the other side, I have given the trial yp of x. Trial yp of x means which we assume in a particular situation. Now, number one is if the right-hand side function is a constant, for example, it is 3, then we assume that yp of x is a. There is some constant. This is your initial guess. Trial yp of this, or you can say this is your guess, an educated guess. An educated guess is what? Which contains undetermined coefficients. And by assuming this as an initial guess, what we do, we assume that this is a solution of that given differential equation. And if it is a solution of that differential equation, it will satisfy the given differential equation. Okay. By inserting this solution into the given differential equation, we can find the value of a constant. That is basically we call undetermined coefficient. In the second case, if the function, right-hand side function is 5x plus 7, 5x plus 7 is what? It is a polynomial of degree 1. In this case, yp, an educated guess, which is, we call it initial guess, it will be ax plus b. Yp will be assumed as a degree 1 polynomial which contains 2 unknown constants, undetermined coefficients. And we need to find these undetermined coefficients by inserting this solution into the given differential equation. Third case, if it is a polynomial of degree 2, for example, 3x squared minus 1. In that case, we assume that yp of x is equal to ax squared plus bx plus c. We assume the particular solution as a second degree polynomial with undetermined coefficients, with unknown coefficients a, b, c. Number 4, and so on. If we have a third degree polynomial, we'll assume the right hand side, particular solution as a third degree polynomial, and so on. Next case is if the right hand side function is 2 sine 3x, or the right hand side function is 3 cos 3x. In both these cases, or the right hand side function is the sum of or the linear combination of these two functions. In that case, the initial guess would be of this form: a cosine of 3x plus b sine of 3x. In both these cases, or the third case as well. Why we assume the linear combination of these two functions? Because when we insert this function into the given differential equation, and that differential equation involves the derivatives of a function, and when we take the derivative of sine, it becomes cos, and when we take the derivative of cos, it becomes sine. So both terms, sine and cos, they will be present in the differential equation. So that is why we assume here a cos 3x and b sine 3x as a particular solution of the given differential equation. In the fifth case, when we have maybe 3 e raised power 5x, an exponential function, then we again assume the yp as e raised power a e raised power 5x, where this coefficient remains same here in the particular solution which we have guessed. This is the undetermined coefficient in this case. Fifth and sixth. Now, we have discussed all the cases separately. Now, if the right-hand side is the sums or product of these functions, okay? For example, product. If we have the product of this and maybe this, okay? So it is maybe 3 times 5x plus 7 times e raised power 5x. Now we have product of two functions. This is what this whole thing is. It is a polynomial of degree 1, and this is what? This is the exponential function. In this case, we take basically the product of these two initial guesses. Okay, ax plus b times a raised power 5x. Now, as we have already a constant here, constant times x plus b, for example, if we assume ax plus b as the guess for this polynomial of degree 1, and यहाँ पे e raised power 5x का जो guess होगा वो क्या होगा? A times e raised power 5x. So we can write a times 5x. But this a will go inside a square and ab, which will again a constant. So we don't write here a constant. We assume in this case e raised power 5x only, because this constant, when we multiply with this, it will play a role of this constant here. So in this case, when we have a polynomial of degree 1 times an exponential function, we take the initial guesses of both cases and take their product as an initial guess. For example, another case, 7, if we have exponential 3x times sine maybe 5x. Okay. Here we have a product of exponential and trigonometric function. In this case, the initial guess or the yp could be what? The initial guess of this exponential of 3x, it will be constant times e raised power 3x, and the initial guess of this function, which is a times cos 3x, b times sine 3x. So when we multiply these two, this constant will be adjusted here. So we assume that yp in this case is e raised to power 3x times a cosine of 5x plus b sine 5x. Okay. So this will be basically the initial guess for the particular solution. Similarly, we can write if we have x squared plus 1 times sine or cos 3x. In this case, we have a polynomial of degree 2 here and a cos here. So in this case, the solution would be, what would be the initial guess in case of polynomial of degree 2? It would be of this kind. Then we can write a x squared plus bx plus c times cos 3x plus in this case ex squared plus fx plus maybe h times sine 3x. Because आपके पास यहाँ पे ये किसके लिए है? This linear combination is for cos 3x, and आपके पास ये जो polynomial of degree 2 है, इसके लिए आपके पास यहाँ पे ये इस टाइप का आपने particular solution assume करना है. Now we have all these situations. How to make an initial guess in order to find the particular solution of the corresponding non-homogeneous differential equation. Let's do now a couple of examples, and then we shall discuss the next topic. यहाँ पे I must have included some example. यहाँ पे this one. Example 1. Solve or find the general solution of the differential equation. Find the general solution of the following differential equation, which is y double dash plus 4y dash minus 2y equal to 2x squared minus 3x plus 6. Now, you can see that this is, first you need to check whether this method is applicable. Check both conditions. First condition is the constants should be, the coefficients of this differential equation, coefficients must be constants. They are constants, it's okay. The right hand side is a polynomial function. It is a polynomial of degree 2. Okay, so this method is applicable. This method is, or the method of undetermined coefficient is applicable. Method of undetermined coefficients is applicable. So we'll use this method to find the general solution of this differential equation. Now, first of all, we need to check this. Secondly, what we do, the general solution is what? The general solution of this differential equation is y of x. It is yc of x plus yp of x. Where yc of x is what? Yc of x is complementary solution. Complementary solution is what? First, we need to find the complementary solution. Complementary solution is what? It is the solution of the associated homogeneous differential equation. Okay. First of all, you need to write associated homogeneous ODE is what? It is y double dash plus 4y dash minus 2y equal to 0. Okay. So we can write this differential equation as d squared minus 4d minus 2 times y equal to 0. And the characteristic equation is how can we write? By looking at this, we can write m squared minus 4m minus 2 is equal to 0. Okay? Now, I hope you can find the roots of this differential equation, and you can easily find the general solution. Sorry, the solution is a complementary function. Find the roots of this, and then you can write y c of x is the answer of this is c1 e raised power minus 2 plus under root 6x plus c2 e raised power minus 2 plus under root 6x. So this is your yc, which is the general solution of the corresponding homogeneous differential equation. I hope you can find it. Now, the next thing which we need to find is the particular integral. Now, how to find the particular integral? We start with the initial guess. In this case, the right-hand side function is a polynomial function of degree 2. So what would be an appropriate or educated guess as a particular integral? Now, the second thing we need to calculate is a particular solution. So the initial guess or an educated guess, you can say, is what? We assume, or you can say that the trial solution is what? Yp of x is equal to, if the right-hand side function is a polynomial of degree 2, then we assume that ax squared plus bx plus c, where a, b, c are constants, arbitrary constants, and we call them, where a, b, c are constants and these are undetermined coefficients, We need to compute these coefficients, these constants. How to compute these coefficients? As we are assuming that this is the solution of the given non-homogeneous differential equation, so this must satisfy the given differential equation. So we are going to insert this thing into the given differential equation. For that, we need to find its two derivatives. So we are going to find y dash p of x. It will be 2a x plus b, and y double dash is what? Y double dash of x is 2a. Okay. Now we have yp dash, yp double dash. Now we are going to insert these values in the given differential equation and try to find the undetermined coefficients. The differential equation was y double dash plus 4y dash minus 2y is equal to y double dash plus 4y dash plus minus 4. So it was minus 2y equal to 2x squared minus 3x plus 6. When this is assumed to be the solution, so if we put it here in the differential equation, it must satisfy the differential equation. Okay. अब इसकी values yp की, yp dash and yp double dash यहाँ पे we are going to insert it here. Yp double dash is 2a plus 4 times yp dash is 2ax plus b minus 2yp is ax squared plus bx plus c is equal to 2x squared minus 3x plus 6. This is what we obtain. Now, rearranging the terms on the left-hand side, how to rearrange them? You try to separate the coefficients of x squared, x, and constant. So rearranging terms. We rearrange the terms here on the left-hand side so that we can compare left-hand side and right-hand side and make the equations. Now, on the right-hand side, we have a polynomial of degree 2, x squared coefficient minus x times coefficient and then constant. So we try to convert this left-hand side in a way so that we can compare both these two sides. So x square को कोफिशिएंट यहाँ पे क्या होगा -2a क्यों होगा x square को कोफिशिएंट प्लस x का कोफिशिएंट क्या होगा x का कोफिशिएंट यहाँ पे है 8a एंड देन x का कोफिशिएंट यहाँ पे है it is -2b okay and then okay plus constant terms constant terms जो हैं वो एक तो 2 है 2a here we have another constant term 4b here we have another constant term -2c equal to 2x squared minus 3x plus 6. Now we can compare both these sides. Now comparing both sides, or you can say comparing like powers of x or same powers of x, comparing the coefficients of like powers of x. Powers of x means x square coefficient, because these two variables, these two polynomials are equal, so the coefficient of x square here must be equal to the coefficient of x square here. Similarly, the coefficient of x here must be equal to the coefficient of x on the left hand side. Similarly, constant must be equal to constant. So we obtain three equations if we compare these two sides. So we obtain -2a is equal to 2, and then 8a minus 2b is equal to 4, and then 2a plus 4b minus 2c is equal to -2. Now, what is this? This is basically a linear system in unknowns A, B, C, which we can solve. We can solve it simultaneously, as well as we can write this linear system. This is your linear system of equations in ABC, which we can write the augmented matrix of this system as -2, 0, 0, 2, and then 8, -2, 0, 4, and then 2, 4, -2, -2. So this is the corresponding augmented matrix, and by reducing this linear system into echelon form or reduced echelon form, we can find the values of these constants, and I hope you can find these values, which are, I'm gonna give you directly these values. The values are a is equal to -1, b is equal to -5/2, and c is equal to -9. So after solving this linear system, we can obtain these values. If we have these values, then yp of x is ax squared plus bx plus c, means a is what? -x squared minus 5 by 2x minus 9. So this is your particular integral. Okay, this is the particular solution which we were looking for the given non-homogeneous differential equation. If this is the particular integral, then we can write the general solution of the given differential equation. This was the given differential equation. Its general solution is what? Thus, the general solution of given ODE is what? It is y of x, and it is yc of x plus yp of x. Okay, yc of x is the complementary solution, which we have already calculated, and it was it was c1 e raised power minus 2 plus under root 6 times x plus c2 e raised power minus 2 plus under root 6 times x plus the particular integral, which is minus x square minus 5 by 2x minus 9. So this is your general solution for the given differential equation. Now further, if we are given initial conditions here, we can find these unknown constants of integration or arbitrary constants by using those initial conditions. I hope you get it. If you have any question, you can ask me. There is a question in the chat window. Sir, 8a minus 2b is equal to minus 3. So, yeah, minus 3. It is not 4. Thank you. Okay. So it is minus 3. So after solving this, we can obtain the constants. I hope you get it. If you have any question in this example, you can ask me. Let's discuss quickly another example. In the case when we have different situation here. If we have this kind of differential equation, for example, this one, minus 5 y double dash minus 5 dash plus 4y is equal to 8 e raised power 2x. In this case, I hope you know how to find the complementary function. We write the associated homogeneous differential equation, which is this equal to 0, and we find the complementary function. I hope you can find the complementary function yourself. Let us find here the particular integral. For finding particular integral, we assume that the trial solution is, or the trial yp is, yp of x is what? You can see that the right-hand side function is an exponential function. So the natural assumption here is e raised power 2x. Okay. Now we need to find this undetermined coefficient a. What we do, we insert this into this differential equation, and we need it. We need the first derivative of this thing, which is 2a e raised power 2x. We need a second derivative of this thing, this particular trial solution, and it is 4a e raised power 2x. So inserting all these values here, what we get in the first term, we have 4 e raised power 2x minus 5 into 2a e raised power 2x, and then plus 4 times a raised power e raised power 2x is equal to 8 e raised power 2x. Now we have to compare both sides यहाँ से e raised power 2x कॉमन ले लें. So what do we get? 4a minus 10a plus 4a times e raised power 2x is equal to 8 e raised power 2x. ठीक है. यहाँ पे क्या आ जाएगा? -2a e raised power 2x is equal to 8 e raised power 2x. Now, these two terms are same here. Now, comparing these two terms, left hand side and right hand side, we get minus 2a is equal to 8 and a is equal to minus 4. This thing. So the particular solution here in this case is what? You take the put the value of a here, 4 e to the power 2x. So this is your particular solution for this differential equation, and we can write the general solution by finding complementary solution and then adding the particular integral or the particular solution in that solution. We can find the general solution of this differential equation. I hope you get it. If you have any question, you can ask me. Let us do the third case as well. Another example very quickly so that you can do other questions. Hmm. This one. I have given these examples in my notes. You can check them out and try to solve. And in this case, we are going to find the solution of this differential equation, y double dash minus 9
Sir, we can't hear you. Sir? Sir? Sir, we can't hear you.
Now, in this example, we are given this differential equation, and the right-hand side is minus 5 sine 2x. Okay, we need to find the general solution of this differential equation. First, we need to check whether this differential equation can be solved by using method of undetermined coefficients. Yes, because the coefficients are constants and the right-hand side function is a trigonometric function, okay, of sine or cos. Okay. Now, I hope you can find the complementary solution in this case by writing the associated homogeneous differential equation here. Now, do it yourself. Particular integral. How to find the particular solution of this differential equation? By keeping in mind the type or nature of the right-hand side function, we assume that the trial particular solution is a cos 2x plus b sine 2x. Okay. And then by taking the derivative of this thing in double derivative, okay, we obtain these expressions. Now inserting these expressions here on this differential equation and then comparing both sides, okay, we can compare the coefficients of sine 2x and plus 0 cos 2x. The coefficient of cos 2x is, you can assume here it is 0. Now you obtain the coefficient of sine 2x and coefficient of cos 2x here, and coefficient of sine 2x and coefficient of cos 2x here. Comparing coefficients of these two, sine 2x and cos 2x, we will obtain two equations here, in A and B, which are undetermined coefficients. After solving those equations, you can find the values of constants A and B, and I hope you can write the solution. I hope you can do it yourself. If you have any confusion, if you have any question, you can ask me. यहाँ पे ये मैंने notes में किया हुआ है, I think. You can see that thing. यहाँ पे the values of the coefficients are basically यहाँ पे ये notes में given है, you can see it. If you have any question, you can ask me. Otherwise, we are going to stop today here. Sorry. So do you have any question? If you don't have any question, we are going to stop it here.